So today we are going to our next step in the reliability, which is understanding who is needed to start the reliability in our plant or the reliability centered maintenance selection of our maintenance processes. As we had explained in the first step, there's the reliability perception from our point of view and the reliability centered maintenance processes which we need to do to reach to a reliable maintenance and operation process. But today it's very important to understand whom we shall need in our journey, operators or maintainers. Classically, we need maintainers to set up the maintenance process. When you select the maintenance tasks and so on, you need the maintainers to select them from the operation maintenance books, from the previous experience, from the history, whatever, and select the best tasks and to upgrade the tasks, maintenance tasks, and the maintenance performance, and so on. But when we are starting our reliability centered maintenance process, we need a little bit different approach. Where this approach is coming from? Let's start first by understanding what do we mean by process. When we have some operation or operation context, or when we have some process that takes raw material, produces a final product, takes some resources and produces waste, this process actually is built up of many interlinked processes. Maintenance is one of them, operations is one of them. Also, there's some core functions, supporting functions, secondary functions, primary functions, and many processes from different parties within the organization to make this product come true. Whether this product is a software product or a physical product, there is an analogy between software products and physical products. They are both depending on interlinked processes. Understanding the link between the different processes is mainly the task of the operations. So, and operations understand better the operations context of the whole machines working together. The maintenance maybe understand the operation of each machine itself, what is inside the machine, how to dismantle it, how to operate it, how to maintain it as a standalone. But when it comes to aligning all the machines to make a continuous production line that transfers the stock or the raw material from one equipment to the other, so reach to a fully needed or a fully sellable product, whether it is a software product or a physical product, that's mainly part of the operations team. So let me take it step by step and we demystify. When the equipment are running, the operations are in charge. Maintenance has a role during this time to monitor the process and understand it better, understand the operation parameters and so on, so we understand when we are retrieving an equipment from a failure, what should happen. When a failure happens, there is no doubt about the failure. Okay, so the failure is clear, something happened, but there's usually a doubt about the reason of the failure, what caused the failure. The operations team, when they are experienced enough, they can understand the context of the failure, how this failure happened, what circumstances led to this failure, what happened before the failure, what happened during the failure, and what are the consequences of this failure. It's better in the minds of skilled and experienced operators than in the minds of the skilled and maintainers. So, because it is related to the complete process, it's related to the complete scenario of the process. The risk coming from the stopping of this equipment, or even the risk coming from a second stoppage of a secondary equipment or a secondary function, you will find it clearer in the minds of the operators than in the minds of the maintenance team. That's why when setting up the reliability centered maintenance, we need the operator and as well as we need the maintainer. We need the operation team members to tell us the context, what their expectation of the machines, and we need the maintenance team to say what we can do internally or what we can do to the machine as maintenance to achieve the targets that is in the minds of the operation. So we need mutual work together, but you will find the context better in the minds of the operators. That's why we need the operators and the operation records while we are setting up the reliability centered maintenance. We can do it alone. Also, it's important to say that operators and maintainers see the equipment from different point of view and see the failure from different point of views, because maybe the maintenance team can see one equipment failing and see the consequence of this the failing of this equipment and see the efforts they need to retrieve the equipment into operation. But the operation team sees the effect of the stopping of this equipment on the other equipment, even if it's a secondary equipment, if it is a control equipment, because we have some control equipment that we use to measure the quality of the product. And if we don't have this equipment that measures the quality of the product, we can stop the complete production line and we lose minutes and hours because we cannot control the quality of the product, and maybe we produce a product that is not sellable and is going to return it to waste, and we lost all this cost on producing this product. All this is in the mind of the operators. Also in the mind of the operators you can find some time, the slip time or gap time between the equipment. So if this equipment stopped, we can wait for 15 minutes, continue the production line, but till we retrieve this equipment in operations. This makes pressurizing with every tick of the clock. It's pressurized, creates a pressure on the maintenance team, because the 15 minutes where they will not stop, the operations will not stop the production line, it's ticking and it's counting down. It's like a countdown that is making pressure over the maintenance team. But actually that's what the maintenance team sees, but actually it's pressure on the operation team also, because their target is to produce. So if the complete line is going to stop, it's a problem for the complete team. It's a problem for the organization, problem for the company itself. So the maintenance need to see the picture more globally, and the operations need to convey their knowledge of the consequences or the interlink between the machines. They need to convey it more clearly to the maintenance team, so we are on the same page. Thank you for letting us hosting this video, and we are advertising our services that we are giving through our own website now. You can order it directly from our website, whether it's coaching and or consultancy. If you need to streamline and adjust your maintenance processes, or even to build maintenance processes from scratch, you can drop us a line, or you can ask for our services directly from our shop or online shop for maintenance and digital services. Thank you for letting us advertising our own work on this material. So another important concept that we need to understand as operators and as maintainers, and you will find it more clear in the operator's mind, the secondary function and the secondary equipment, the concept of secondary equipment and secondary function. Secondary equipment, for example, you can see that the transportation pallet at the end of the production line that transfers the finished product as a secondary equipment, because anyhow the final product will come out without the use of this transportation pallet or transportation truck. But if this transportation pallet or truck is not working, the production cannot continue, because the final product will be accumulated at the end of the line, and the complete line will stop because this secondary equipment is stopped. Secondary equipment also can be a measuring equipment for the control of quality of the production, so you cannot run the production line without controlling the quality. Also secondary equipment, if you are taking an air flight, and for the airline the coffee machine is a secondary equipment. It will not stop the flight from taking off and landing on time, and that will not jeopardize the safety of the flight. But actually the customers will not be happy. Maybe on the next booking they will not book on the same airline because they don't have coffee offered on their flights. Okay, so that's concept of secondary equipment, but it's important equipment and it's in the mind of the operators. From the secondary functions, for example, the secondary function of a pump is to contain the liquid it is pumping. If there is some leakage, either you will lose some of the production parameters, or you will create a risky condition. This also is in the mind of the operators, that we need to take it out and put it on paper and put it as part of our preparation for the reliability centered maintenance. Regarding the soft product, if you consider this article we are producing or this video we are producing as a soft product, actually it passes but many interlinked processes: preparation, writing, editing, recording, video editing, posting it on the social media. And if there are many people performing these activities, then this is a complete interlinked process where someone can be delayed in performing his job because the one before him or the one after him are delaying the job. That's what we mean by interlinked processes that affects each other and affects the cost of the complete process. So even a soft product is a set of interlinked processes, not a single product. So there's one point that we need to understand clearly from the maintenance point of view, which is the operator's expectation. Maybe the operator's expectation is higher than the actual capability of the machine. This could be a problem from the operations, and it could be a problem from the design itself. That's why the reliability-centered maintenance gives us an opportunity to say as a conclusion that we need to change the design of the machine. For example, if I have my machine is designed for 900 meter cube of water delivery, whatever the unit of time you are selecting, that's for cooling. And the minimum needed for cooling is 900 meter cube. So with time, there's wearing in the equipment and this flow decreases. So the quality of the cooling decreases, the quality of the product decreases. Maybe we need to slow down, decrease the temperatures of the production and so on. And this is not optimum, will not allow us to create an optimum product in the matter of quality and in the matter of quantity. But actually, the pumps available are designed for a maximum capacity of 900 meter cube, which cannot be sustained continuously for a long time. That's why usually we need to design our equipment to having a surplus capacity of 5% or 10%. So it gives us a time between maintenance and maintenance. So we have a time between maintenance till it drops from 900. Yeah, so I purchase it for 1000 or 1100 meter cube delivery. Then I have a time until the delivery stops. And maybe for some sophisticated systems, we have some online backup electronic cards or CPUs and so on, or hard disk or sensors that can back up the operations. So we don't need to stop the operations for the failure or partial failure of one equipment. So maybe the expectation of the operators is due to real problems, or maybe it is a problem from the design that we need to correct it. Maybe also, or we need to know that maintainers usually like to see the machine out of its context. They like to see the machine as a standalone. They can open it, work with the parts inside it, refurbish it, return it to the operations as per the book. But the problem is within the operation context, maybe what is written in the book as operation parameters is not actually what is used by, or the usage by the operators, and this is not reflected to the single operator or standard operating procedures. So it needs to be reflected there. That's why we need the operators to understand how is the real conditions of the operating of the machines. Also, this is a great opportunity to study your systems, to study your operations, and we can give you a hand and support this, as we said before. Join, subscribe, spread the information. See you in coming videos with more insights from simple ways for maintenance.